In this section, we will walk through creating drill patterns, blast pattern loading, and configuring pattern timing sequences. The first method for creating a drill pattern is using the A-B line tool. Simply click on the map to set your start and double-click at the endpoint. This instantly establishes the baseline and orientation to generate your drilling grid. Once your line is set, you can easily flip the pattern's direction or expand your grid by adding more rows. To fine-tune the design, you can easily adjust the burden and spacing. Increasing the burden widens the distance between rows, while adjusting the spacing changes the distance between individual holes. This gives drill and blast engineers complete control to manipulate the pattern exactly to their specifications. To customize your blast pattern, you can easily change the shape and layout. You also have the flexibility to choose between a standard square grid or a staggered layout, depending entirely on your site requirements and drilling preferences. Another way to generate your drilling grid is by using A-B points. Instead of drawing a continuous line, simply click to drop individual points on the map. This automatically establishes your baseline and populates the drill holes. For irregular blast patterns, use the polygon tool to outline your exact boundary. Simply trace your desired area, and once closed, the system automatically populates the drill holes inside that shape. From there, you can easily adjust the azimuth to rotate the entire grid. As you change the burden and spacing, the system automatically adjusts the holes to fit your drawn area. You can also toggle auto-fit or stagger the rows. For maximum safety and precision along a high wall or bench face, you can use the Trace Crest tool. Simply select the crest line and set a specific offset, such as 2 meters from the edge. The system will automatically design your drill pattern to follow the exact geometry of that crest, ensuring your front row maintains a safe distance from the bench face. You can also upload your pre-existing drill pattern data from another software. If you fly a site that has already been drilled, you can use Drill Hole AI. The AI will analyze the imagery, automatically detect the physical holes on the ground, and generate the digital pattern for you. Finally, you also have the option to simply copy a proven drill pattern over from a previous project. To accommodate specific blasting requirements, you can adjust the drilling angle for your pattern. If your design requires angled holes, simply input your desired inclination, such as 5 degrees, and the system will automatically apply that angle across the entire pattern. You can also account for backbreak in your design. When explosives detonate, some energy inevitably travels backward, breaking rock behind your last row of holes. By entering a backbreak value like 1 meter, the system automatically includes this extra material in your total blasted volume calculations for accurate reporting. Next, you need to define the diameter of your drill holes. This is a critical parameter, as the hole size dictates exactly how much explosive material can be loaded, which in turn determines your optimal burden and spacing requirements. Next, set your subdrill depth. This parameter defines the extra distance drilled below your target floor, ensuring a clean, level bench after the blast. To keep your blast plan organized, you can easily apply continuous hole numbering. By selecting your preferred direction, the system will automatically number every hole in sequence, for example, from hole 1 to 97, ensuring a clear and logical layout for your team in the field. Finally, you can manually enter a target elevation or design directly to a floor plane. By selecting the floor plane tool, you can base the depth on your uploaded model. Simply double-click on a specific area, and the software will automatically snap the holes to that model surface. This allows you to drill at specific grades and angles, which is perfect for building structures like ramps into your blast plan. Simply click Create to generate your finalized drill pattern. Now that your pattern is generated, let's explore some of the powerful tools available to review and fine-tune your design. To modify a specific group of holes, simply hold the Control key and drag your mouse to create a selection box. Once your target subset is highlighted, use the Edit Selected Holes tool to apply bulk changes, such as updating that entire row to a 10-degree drilling angle. To quickly confirm those changes, you can toggle into the 3D view. This allows you to visually verify the new drilling angles. Editing specific holes is simple and intuitive. You have multiple ways to make selections. For instance, you can hold the Shift key while clicking to select several individual holes across your pattern for targeted adjustments. Once your target holes are selected, you can easily access and edit their individual properties. This menu gives you total control to modify all the specific details and parameters that define exactly how each hole is structured. You can also analyze the hole burden along the bench face. This feature is especially critical for quarrying operations, as it ensures your front row holes maintain a safe, optimal distance from the open face to prevent face burst and fly rock. If the analysis shows that certain holes fall below your safety threshold, you can easily correct them. Simply select the problem hole and move it further back from the face. As you make the adjustment, the system dynamically updates the burden metrics in real time, instantly confirming that your new position is safely within the required limits. For a more comprehensive view, you can also review these minimum face burden distances in a table format. This allows you to verify the data for your entire front row, all in one place. Next, you can analyze your individual shot volumes. The software generates a bounded area, or polygon, around every single blast hole. This provides a clear visual representation of the volume of rock that specific explosive charge is expected to break. Once your pattern is finalized, you can export the drill plan directly to smart drills like Epiroc, Sandvik, or Trimble Groundworks. Alternatively, you can send the data straight to GPS rovers for manual stakeout in the field. Now we will move into the loading and timing module. Let's start with the loading design, which allows you to define exactly how each hole will be packed with explosives and stemming material. In this step, we will define exactly how to load the holes with explosives, as well as the stemming material used to cap them. To build these profiles, users can quickly select their specific materials directly from a customizable site product list. This comprehensive list contains all the various products required for a blast. You have complete flexibility to edit the list and add the specific materials used on your site. If a specialized product you need isn't currently available, you can submit a request for review to have it added to your database. To complete the loading profile, you will also add primers and detonators, or loggers, which control the exact timing of when each hole will fire. You can build out highly intricate loading designs by applying specific rules for your explosives, primers, and stemming material for use cases such as pre-split holes. Once your pattern is fully loaded, the system automatically generates detailed documentation. With just a few clicks, you can review and export comprehensive loading sheets and explosive usage reports. Once your holes are loaded, the next critical step is timing the blast. This tool allows you to sequence exactly when each individual hole will detonate. There are 3 different ways to sequence your blast. One method is to simply draw a continuous line across your pattern. For example, if you trace along the front row and finish the line, the system automatically assigns initiation times to each hole starting at 0 milliseconds at equal intervals. Another option is the drag tool, which functions like a paintbrush. By simply clicking and brushing over the holes, you can incrementally apply timing delays. The system dynamically updates the initiation times on your screen as you sweep across the pattern. The third and most advanced method for timing simulation is geometric timing. We begin this process by creating 2 primary vectors on the sides of the blast pattern. This defines our initial initiation points and sets the desired direction of movement for the outer sections of the bench. Once these 2 vectors are perfectly positioned, we use the Connect tool to link them together. By connecting these vectors, the software automatically calculates a timing progression across the gap, ensuring the firing sequence flows smoothly across the entire face without any awkward timing interruptions. Before moving further, we can verify the results of our positioned vectors using the dashboard above. By toggling the required feature tools on, we get instant feedback on the angle of inclination, throw direction, and burden relief. This is a critical step. It allows you to see exactly how the rock will respond to the current timing. You can visually confirm that each hole has a path of least resistance and that the energy is being directed exactly where your design requires for optimal fragmentation. To make complex designs even easier to manage, we can divide the blast into specific groups. As you see here in the demo, I've created Group 1 and Group 2. This is incredibly useful when you need independent control over different sections of the blast, perhaps due to a change in geology or a specific high wall constraint. From the left-hand menu, I can move or change the parameters for each vector specifically for its assigned group. By establishing a vector for Group 1 first, and then a separate one for Group 2, we gain total authority over how each zone behaves. This grouped approach allows us to customize the timing logic for varying conditions across the bench. Beyond standard vectors, we can also integrate the circle tool or the diamond tool to refine the initiation shape. These tools allow for radial or complex multi-directional patterns that would be nearly impossible to calculate manually. As you adjust these, the system continues to update your relief and throw data in real time, keeping your design accurate. We finish the process in the breakup charge window. This ensures we are managing the maximum charge per delay to keep ground vibrations within safe limits. This entire workflow, from connecting vectors to managing groups, turns a complex engineering task into a fast, intuitive, and highly precise design process. We can use the visual tools at the top to perform a check on our design. By monitoring the instantaneous holes, burden relief, and throw direction, you can verify that every delay is perfectly optimized for safety and performance before finalizing your blast. Once your timing is set, you can run a visual simulation of the blast. By adjusting the playback speed, you can watch the exact initiation sequence unfold. This animation clearly demonstrates exactly when each hole will detonate and gives you a great visual of how your material is expected to move. Next, we have timing intervals, which are especially important for our quarrying customers. Because blasting is strictly regulated, operations are often constrained by the 8-millisecond delay rule to control ground vibration. This timing graph provides a clear visual breakdown, allowing you to instantly verify exactly how many holes are detonating within any given 8-millisecond window to ensure full compliance. The software generates comprehensive timing reports. When you are ready to execute the blast, you can export this exact timing data directly into your electronic initiation systems.